Namaskar, I am Ashok Kumar Gupta with video on solution. In this video, I will discuss with the definition of solution, solvent, solute, then types of solution and how to express the concentration of solution. A solution are homogeneous mixture of two or more than two components. Homogeneous means that the properties of the solution is uniform throughout. Look here, we cannot find different substances in this solution, but here in this case, this is the component one component, and this is the other components. So we can say that this is heterogeneous. Why? Because there are two different phases present in this mixture, but this is homogeneous. Why? Because there is only one phase. The property of this mixture is uniform throughout. So this is homogeneous and this is heterogeneous. We come across some terms like solvent. This is the component present in the solution in largest quantity. The major proportion is that of the solvent. In other words, we can say that when two substances are mixed, then the one which is in major proportion will be called solvent, and the other one which is in a smaller proportion will be called solute. There may be many components. Depending upon the number of the components in the solution, it is called binary, tertiary, quaternary solution. A binary solution contains two components. A tertiary solution contains three components, and a quaternary solution contains four components. Now we'll discuss the type of solution. The type of solution depends upon the physical state of the solvent and solute. See, depending upon the nature of the solute and solvent, we can classify the type of solution into three categories. One, gaseous solution, two, liquid solution, and three, solid solution. As we have discussed that the physical state of the solution depends upon the physical state of the solvent, as because this is the major component. So when the solvent is gas, then the solution will be gaseous solution. What about solute? Solute may be gas, may be liquid, and may be solid. If the solute and solvent both are gas, then the mixture, the solution formed is gaseous. Example is air. If the solute is liquid and the solvent is gas, then also the solution formed is gaseous solution. Example is water, vapor in air. Similarly, if the solute is solid and the solvent is gas, then the solution formed is in gaseous state, and the example is smoke particle in air. Now let us look at the liquid solution. In liquid solution, the physical state of the solution is liquid. This happens when the solvent is liquid. What about solute? Solute may be gas, liquid, and solid. If the solute is gas and the solvent is liquid, then we get a solution. Example, aerated water. When both solute and solvent both are liquid, then we get a solution which is in liquid state. Example, ethanol in water. Many more examples you can find in your textbook. When the solute is solid and the solvent is liquid, here the solid should be soluble in a liquid. Then we find a solution in a liquid state, and example is sugar in water. Another type of solution is solid solution. This is formed when the solvent is in solid state. The solute may be gas and the solvent is solid. For example, hydrogen gas adsorbed on palladium. Then the solute may be liquid and the solvent is solid. For example, mercury amalgam. When the solute is solid and the solvent is also solid, then we get alloys. So these are the three different types of solution based on the nature of solute and solvent. Now we will discuss how to express the concentration of solution. The first one is mass percentage. Mass percentage can be defined as the mass of the component in the solution divided by the total mass of the solution into 100. The other one is volume percentage. The volume of the component in the solution divided by the volume of the solution multiplied by 100. This is volume percentage. Look at this example. Suppose we have 40 ml of a solute and some water is added to make it 75 ml. Then what will be the percent volume of the solute? Percent volume is equal to how much? 40 divided by 75 into 100 is equal to 160 divided by 3, right? So it will be about 53.33% approximately, right? So this is the volume percent. Now parts per million. This is the part of the solute present per million of the solution. So how to calculate? Mass of the solute divided by the total mass of the solution into 10 power 6. This parameter is needed when the concentration of the solute in the solution is very, very small. Then we express the concentration in parts per million. If they are in liquid state, then the volume of the solute divided by volume of the solution into 10 to the power 6. That is the volume of the solute present per million volume of the solution. We can also express parts per million mass by volume. The formula will be mass of solute in gram divided by volume of the solution in ml into 10 to the power of 6. Mole fraction represented by X. Mole fraction of a component is the fraction obtained by dividing the number of moles of that component by the total number of moles of all the components present in the solution. If N1 and N2 are the number of moles of the solute and the solvent respectively, then the mole fraction of the solute X1 and that of solvent X2 may be given by the formula X1 is equal to this formula. X1 is equal to N1 divided by N2 plus N1 and X2 is equal to N2 divided by N1 plus N2.